There's solutions for everything, but it depends on what your use case is. But now, when something that happens in a larger application, you have a database, your database starts scaling, your first line of defense against your database being too difficult or too slow is caching. So just like you cache in memory what's happening on your computer, in a database you cache your queries, you cache your objects. If you're huge, if you're manipulating objects in memory, or you have user information that you pull in that is something that isn't just a simple database transaction, you can store it and pull it up later with ease. And basically you get random level access. Is that a question?
No, I was asking what do you do for it? And that was
okay, yeah. So what do you do? So usually QI. So solutions for caching. Memcache is a big one, classic. It's a simple key value store where you store a key and then you store a string, which is usually just like a serialized, your object. If you're in Java, you serialize, or if you're in Python, you pickle your object and put it into your key value store, and then you unpickle it to pull it out. There's client libraries and a web API. This is a well-supported technology that's used by a lot of people. The one thing is it uses LRU, which is least recently used, which is fine for a lot of applications, but if you have custom memory management needs, then you kind of are stuck with just using LRU. Redis is the new and upcoming, the new guy on the block. It's Memcache with a lot more added features that make it a lot better for most use cases. There's occasionally you go back to Memcache, but for the most part, everything new. If you're building something new, you should look to use Redis. You can store more than just strings. So picture this kind of more like a NoSQL database where you can store your objects as JSON or whatever you need. You don't need to serialize like you did with Memcache. Is that a hand raise?
Yeah. So Redis also does distributed stuff, right? So
yes.
And is Memcache also for distributed? Is this distributed caching?
Yes, these are distributed caching. So these are solutions where they're as big as your memory pool is in your cluster.
I see. Okay.
So this isn't limited per machine. So I don't know if I made that clear. And then I give EH cache, which is an example of a Java-specific cache, but there's tons of different caches that are out there. Oh yeah, Redis also has more functionality like message brokering, so you can do queues and stuff with Redis. So speaking of queues, when you have a web application, oftentimes you're doing larger tasks that take a long time. I'm sure Kevin probably ran into this with resumes and with processing resumes, but you can't process an entire resume in the time you send an HTTP request and back. You need to do some form of asynchronous work. So this is where a queue comes in. Tons of different queuing mechanisms out there, but the main idea is you have a queue, and then you have workers that consume that queue. You can scale your workers. You can have hundreds of servers that are just consuming your queue, and scale down as when you only have one or two requests coming in, you don't need 100 servers out anymore. So that really lets you do a lot of scalability with ease. Some examples of stuff you would use: Apache, ActiveMQ, RabbitMQ, ZeroMQ. Like I said earlier, you can use Redis for queuing. There's a ton. I gave a website link here. It just basically breaks down a lot of the different ones with your use case. So you have all this fancy stuff going on. Now you have to monitor it, right? So you need to make sure that everything's running smoothly. So this right here is just kind of a silly picture, but if you look closely, you can see it's just server.log and then a date after it, and there's hundreds of these files. So this is not a sustainable solution. If you're having problems, you don't want to SSH into your server and go through each one of these files or grep write a script that greps through these files to try to find what's going on. You need something that's a little bit better. Also, on the side note of this, something like this could easily crash your servers in production. You run out of disk, you have a web server, and you store all your server logs on your server, and you're storing everything. At some point, your disk is going to fill up, and what happens then? So you need to be able to alert, and you also need to be able to manage your systems. So while you're doing this, you should log to let you know what's happening in your systems in case anything goes wrong. So some monitoring software that people use, this is an example of Kibana, but there's, for data visualization and log processing, a lot of people use Elasticsearch, Logstash, and Kibana, all open source software that runs and supported. You can get managed instances too if you don't want. There's also Splunk, New Relic, Grafana. There's a ton of different things out there for log processing. There's also performance and state monitoring. So a lot of these tools you can do both log processing and viewing as well as performance monitoring. But performance monitoring can be a lot more useful for alerts that you might not get with just looking at your logs or looking at CPU usage. So something like Zabbix or Nagios, Cacti or Datadog all allow you to do everything from sending a ping every 3 seconds to your server, and if it responds, and then if it responds within 1 second, then it's up. But if it takes longer than a second, then send an alert. Or even more complex things like if this server doesn't respond, but this one does, you can program it to do basically anything you need to describe what your architecture is doing wrong or might do wrong. And this is basically just like setting up little sensors like your hardware guys might do in the car to see what's going on. Really important. You don't want to find out the next morning when you wake up that your disks were completely full, so there's no writes to your database the entire night. You gotta alert for things like that. What was that?
That's why you don't sleep, right?
That's why I don't sleep. Yeah, most people sleep, especially if they're working all day. So with monitoring of them, there's a huge trade-off between rolling your own, saving money, but then spending more time setting up, processing. There's a ton of different tool chains out there. You really have to pick what works well with your product and your domain knowledge. The other thing to think about is when you're processing, if you're outsourcing your log management or your processing, you have to make sure your logs are clean. So don't send your authorization logs if on an error it prints out the username and password that was attempted or something like that. You can't send that kind of data to other companies, or you definitely should. You shouldn't be sending that to your logs, period. But if you're going to, it should be in-house. So that's kind of a basic overview of the architecture of the system. Just a couple different sections and what you need. I want to talk a little bit more about deploying and what happens now. Does anybody have questions about anything I covered so far? Do you guys have a picture of what you might be using if you're building a web app? Yes.
I have a question about stuff, but I don't have any sort of picture.
Okay.
So, if you have these distributed systems, right, and you have this distributed database, is it such that pieces are on each server, or the whole thing is on all servers, or?
So that's a design decision right there.
Okay.
That's where a lot of people try to worry about scaling their database last. You want to do as much as you can to not, just because it's a lot more complicated problem. But there's a lot of different ways. Mostly it's a clustering thing, where the easiest solution is you have one master that does writes, and then you have replicated servers that you can do reads off of. So all your writes go to one, and then all your reads can come from any of the other ones. Basically, it just takes load off the main server. But obviously, that only scales up to a point as well.
Right.
Once you get past something like that, there's also sharding. So you can have your database. This is kind of more of a Mongo thing than, but there's concepts and other things. But you have different nodes that are responsible for that information. If you're writing data about an object, you're only ever writing it to one database, and that database is the know-it-all on that subject. Everybody else can read, but And that's useful, but that gets into really complicated of how you pick your shard. So how do you pick whether, your server in New York or your server in California or, your server in China gets that information? You have to keep in mind where the requests are coming from, stuff like that. Does that answer your question?
Yeah. And then replicating is hard, right?
And replicating is fairly hard, yeah.
Okay.
How do
Back
you,
further, sorry.
how do you test your continuous delivery before you actually do it? Like, is it very common to break during that step? And how do you do that securely and not fry it?
So I think Stack Overflow is a good example of this. I think Sebi's talked about this before, at least with me. But the idea is, with continuous delivery, you can roll out to a subset of servers, and if things fail, then you can that and just roll back. So there's a lot of smart systems that are built into that. Even Ansible will let you run against like 1,000 servers, and if anything over 10% of the servers are failing to launch, or 5% or 1%, whatever percentage you want to say is like an acceptable failure rate, because things can fail for like non-code reasons. But if it's starting to get to 5% of your servers are failing, there's probably either a code problem or a network problem or a configuration problem of some sort, and you can have them cancel deployment, stuff like that. The main point of continuous delivery is you have basically feedback mechanisms. So you have to have tests that already went through your continuous deployment kind of stuff. You have a really good dev program, but then with continuous delivery, you also need to be able to get automated feedback from users or from clients. Yes?
What's usually like the number of continuous users at one point that you can have before you have to start scaling up to massive systems like this?
Completely dependent on your application. So you can have thousands of people using like one server if you're just doing simple like messaging relaying or something like that, if you have an efficient server. Whereas if you're doing image processing, you might be able to fit like 5 people on a server. So it's completely dependent on what you're doing. That's a bad answer, but it's, yes.
Kind of a comment. So when you were talking about